In this lecture, we are going to discuss the definition, calculation, and interpretation of risk difference. The risk difference is defined as the difference between the risk of disease among exposed and the risk of disease among unexposed. It is calculated as the risk of disease among exposed minus the risk of disease among unexposed. For example, let's have lung cancer as the disease and smoking as the exposure. The risk difference would be calculated as the risk of lung cancer among smokers minus the risk of lung cancer among non-smokers. The risk difference has a pretty simple interpretation. If the risk difference is a positive value, it means that the risk of disease is higher among exposed. If the risk difference is a negative value, it means the risk of disease is higher among unexposed. A risk difference of 0 means there is no difference in the risk of disease among exposed and unexposed. Let's have a look at how to calculate risk difference and its 95% confidence interval. We will use a 2x2 table of risk factor status against disease status. The formula for risk difference is given below the 2x2 table. The formula is A divided by A plus B minus C divided by C plus D. In this formula, A is the number of people diseased among exposed group, and A plus B is the total number of people exposed. C is the number of people diseased among non-exposed, and C plus D is the total number who were unexposed. To calculate the 95% confidence interval of risk difference, the formula is risk difference plus minus 1.96 into standard error. 1.96 in this formula is the Z critical value for 95% confidence interval from the Z table, and the formula for standard error is given here.